Hello students, welcome to today's max class. Today we'll be discussing about the concept of probability. What is the meaning of probability? Probability is the branch of math that studies pattern of chance. So it is all about chance. Okay. And what is the definition? It is the ratio of favorable outcome to the possible outcome. Okay. Probability is the measure of how likely some event will occur, a number expressing the ratio of favorable cases to the whole number of cases possible. That is, P of A is equal to number of favorable outcomes by total possible outcomes. You can write this as P of E or P of A. Anything is fine. Okay, friends. And before knowing probability, you need to know some of the terms which is related to probability. Before we explore more into probability, these are the common terms used. Okay, experiment. So experiment is nothing but a chance or probability that leads to result. You know the outcome. Okay, but in random experiment, you know the outcome, but you're not sure of the outcome. The best example is tossing a coin. So tossing a coin, you know for sure when you toss a coin, you will get either a head or a tail. But you're not sure. You're not 100% sure when you toss a coin, you will get only head. There are 50-50 chance, right? 50% you have a chance of getting head and 50% you have a chance of getting tail. Okay, so this is a best example for random experiment. Okay, but normal experiment, we know the outcome. Okay, for class 12 students, you would have went to chemistry lab and performed some experiments, especially in titration. You use the solution, right? Different chemicals, and then you know the outcome, right? After you mix up with this solution, you know at the end of the titration, it's going to turn, the color is going to change, right? It could be a pink color or it could be orange. So you know that will be the ultimate result. Okay, that is called experiment. But in random experiment, you know the outcome. You know definitely you will have a head and the tail could be the outcome, but you're not sure what will be the outcome, right friends? So this is called random experiment. Okay, so outcome is nothing but a possible result of a experiment. Equally likely outcome is all outcomes with equal probability. Okay, so these are some important terms you should remember. And the next important term is sample space. The set of outcomes of an experiment is a sample space. Okay, what is an event? One or more outcomes in an experiment is the event. Sample space, for example, I'll just explain you. Okay, suppose if you're going to say for example, all right, say for example, if you're going to roll a die, all right, what could be the possible outcomes? The possible outcome, it could be 1, it could be 2, it could be 3, it could be 4, it could be 5, it could be 6, right? So you have totally how many possible outcomes? 1, 2, 3, 4, 5, 6. So here the sample space is represented by S. S is represented, okay, the total possible outcome is 1, 2, 3, 4, 5, 6. So N of S is equal to 6, the total possible outcome. Okay, N is nothing but number of, okay, and S is the sample space, the total possible outcome. N of S is equal to 6. Okay, so this was the best example for a sample space. Sample space is nothing but the set of outcomes of an experiment. So when you roll a die, what is a possible outcome? You will get 1, 2, 3, 4, 5 and 6. Okay, this is called sample space, set of possible outcome. So what about this 1, 2, 3, 4, 5, 6? Okay, these are all called sample points. Each element in the sample space is called sample point. 1 is a sample point, 2 is a sample point, 3 is a sample point, 4 is a sample point, 5 is a sample point, and 6 is a sample point. Okay, students. Next, what is the meaning of event? One or more outcomes in an experiment. That is called event. Okay, so it could be any event, right? The sun is shining bright. That is an event. Okay, something is happening. Okay, that is called event. When you toss a coin, it is an event. When you roll a die, that is an event. Okay, what is the meaning of sample point? Each element of the sample space is called sample point. Just now I explained. So each element here, 1 is element, 2 is element, 3, 4, 5, 6. All these are sample points. Okay, students. So the definition for P of A is number of times the desired outcome divided by the total number of trials. So you can write this as, okay, I'll write it here. P of A is equal to, okay, this is the formula. P of A is equal to N of A divided by N of S. N of A divided by N of S. Number of favorable outcomes divided by the total possible outcomes. So this P of A is nothing but probability of success. Okay, and then events are mutually exclusive if they cannot occur together. That is also important definition you should remember, mutually exclusive events. So now we'll discuss about the type of events. The first one is simple event. If an event has only one sample point in a sample space, it is called a simple or elementary event. Okay. If then compound event, just the opposite. If an event has more than one sample point, it is called a compound event. And the next important, mutually exclusive event. So mutually exclusive event is nothing but an event in which both the events cannot occur simultaneously. Okay, both the events cannot occur simultaneously. That is called mutually exclusive events. Okay, students. So you can take this example. You have set A 1, 3, 5. Set B you have 2, 4, 6. So A and B, both the sets does not have any elements in common. In that case, you can say A and B are mutually exclusive events. So here A intersection B is equal to nil phi. Alright. So this is an example for mutually exclusive event. Okay, students. So don't get puzzled. Alright. Very important topic, mutually exclusive event. Another example, if I think of, it is tossing a coin. Okay, when you toss a single coin, will you get both head and the tail at the same time? No. Either you should get a head or you should get a tail. Both the events cannot occur at the same time. So that is called a mutually exclusive event. Okay, students, and remember these important rules. So probability should be between 0 and 1. Okay, the sum of all the probability is of the sample space is 1. Okay, then where is probability used? Probability is used a lot in day-to-day life. It is used in math, statistics, finance, gambling, science, machine, artificial intelligence. So all these fields, probability is widely used. Okay. Next, probability of a sure event is always 1. Okay, sure event in the sense like sun always rises in the east, so definitely it's a sure event. Okay, so the probability of success will always be equal to 1. And the next probability of impossible event will be 0. Okay, the sun will never set again. Is it a impossible event? It is a possible event, right? So this is the best example for impossible event. Next, the addition rule, you have to remember this. Okay, P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay, this rule is applicable when the two events A and B are not mutually exclusive events. I'll explain that later. When we solve the problem, you will know. Okay, but remember this addition rule. P of A union B is equal to P of A plus P of B minus P of A intersection B if both A and B are not mutually exclusive. If A and B are mutually exclusive, then you can say P of A union B is equal to P of A plus P of B. Okay, here P of A intersection B will be 0 because nothing in common. So it will become 0. So we have the formula. If it's of mutually exclusive events, P of A union B is equal to P of A plus P of B. Alright. And then as I told earlier, okay, if the probability, if the event is sure, certain, the probability is going to be 1. And sum of the probabilities will be equal to 1. Then next important, complementary events. The complement of event is a set of outcomes in the sample space that are not included in the outcomes of the event. Okay, that is called complementary. So what do you mean by complementary? Suppose if you are going to throw a die. Alright. Okay, suppose if you are going to throw a die. Alright, if you're going to throw a die, now what we will do is, okay, the favorable event, okay, we'll say some favorable event. So what we will do, you will be, when you throw a die, you have to get a even number. Okay, so the favorable event, for example, the sample space, when you roll a die, you will get either 1, 2, 3, 4, 5, 6, right? And the favorable event is getting even number. Okay, so I can write this as A is equal to, I can write the sample space. So what are the even number? 2, 4, 6. Okay, so this is the favorable outcome. All right. Okay, but the question is, A is getting the even number. If not even number means, I will represent this as A dash or A bar. So A bar is nothing but, so you have obviously odd number, right? It could be the 1, it could be 3, it could be 5. Correct, students? So this A dash is called complementary of an event. A dash, the event which is not getting an even number. Okay, so this is called complementary of an event. Understood, students? Next, sample space we already discussed is a possible outcome. Each point in the sample space is called sample point. Now we'll see some example, okay, picturing the sample space. Consider rolling a die, one die. In a single roll of die, there are 6 possible outcomes. We know that it's n of s is equal to 6. Now you have to find the probability. Okay, you have to find the probability here. Find the probability as the occurrence of number greater than 4. So when you roll a die, you will get either 1, 2, 3, 4, 5 and 6. This is the total possible outcome. Am I right, students? So n of s is equal to 6. Right? N of s is equal to 6. Favorable outcome, it should be greater than 4. So greater than 4 means it should be either 5 or 6. N of a is equal to 2. Total favorable outcomes. Okay, because the sample space for a, the favorable outcome is 5, 6. Correct? And the total possible outcome is 1, 2, 3, 4, 5 and 6. Okay, we know n of a, we know n of 6, n of s. So what is p of a actually? P of a is n of a divided by n of s. Just substitute n of a divided by n of s. So what is your n of a? We have 2 divided by s. N of s is 6. So both are divisible by 2. So it is 1 by 3. Your probability of success is 1 by 3. That's it. Understood, students? Okay, so you can pause the video and you can just make a note. Whatever I'm taking in the video, please write it in your max classwork. Okay. And the next, finding the sample space for rolling 2 dice. So if you have 2 dice, how you are going to write the sample space? You have 1 comma, you have die 1, you have 1, 2, 3, 4, 5, 6, die 2, you have 1, 2, 3, 4, 5, 6. So this is how you are going to write the sample space. So 1 comma 1, and then you can write 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6 here. Similarly 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6, 3 comma 1, 3 comma 2, like that it goes on till 6 comma 6. So total possible outcomes for rolling 2 dice will be 36. Okay, students, for 2 dice. Single die means we know it's only 6 for 2. Okay. Next, tree diagram. So this is the diagrammatic representation of tossing a coin and a die. Okay, the first one is tree diagram. So when you toss a coin, you have head and tail. When you roll a die, you have 6 possible outcomes. 1, 2, 3, 4, 5, 6. Here also you have 1, 2, 3, 4, 5, 6. Similarly, for tossing the coin 3 times, you have head and tail. Here also you have head and tail, head and tail, head, tail, head, tail, head, tail, head, tail. So this is how we are going to write head, head, head. H, 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 T, H, T, H, H, T, T. Okay, then you have T, H, H, you have T, H, T, T, H, T, T, H, T, T, T. So you have totally 8 possible outcomes. Okay, so here the question is, what is the probability that tossing a coin 3 times will result in 1 head and 2 tails? Okay, so now we have drawn a tree diagram. When you toss a coin 3 times, this is the total possible outcomes. Okay, but the question is, what is the probability which will result in 1 head and 2 tails when you toss 3 times the coin? Okay, so for that, we know n of s is 8. Total possible outcome is 8. So we have the sample space written. But what about the favorable outcome? It should be 1 head and 2 tails. So 1 head, where I can check 1 head. Here you have 3 heads. Here you have 2 heads. Here you have 2 heads here. Here, yes, HTT, 1 head and 2 tails. Here you have 2 heads. We cannot take that out. Here you have 1 head and 2 tails. Yes. So I can take this one, right? I can take this one, HTT, and then I can take THT, and then I can take TTT, right? HTT, THT, and TTH. Okay, so how many favorable outcomes you have? 3. So n of a divided by n of s. So n of a is 3 divided by n of s is 8. So this is how you're going to find the probability of tossing a coin 3 times, which results in 1 head and 2 tails. Okay, students, you can make a note. Next is the formula. P of A is number of favorable outcomes divided by number of possible outcomes. Remember this, P of A is n of A by n of s. P of A is probability of success. Okay, P of A bar is your complementary event. Okay, P of A bar is 1 minus P of A, 1 minus probability of success. Okay, what is this P of A bar? P of A bar is nothing but your probability of failure. So adding this to P of A plus P of A bar will always be equal to 1. Remember this key points here. Okay, you can make a note, and then we'll be discussing about one more problem in this. Okay, students. So take down the problem. 2 dice are thrown. The question is find the probability 6 obtained as product. So 2 dice are thrown. So 2 dice are thrown means your N of S is 36, right? You have, this will be your sample space, right? 1, 1, 2, 1, 3, 1, all this will be your sample space. Corrections, but here the question is find the probability in which 6 is obtained as the product. So when you roll the 2 dice, you should get 6 as a product. So take for example, if I take 1, 1, 1 multiplied by 1 will give you 1, 2 multiplied by 1 will give you 2, 3 multiplied by 1 will give you 3, 4 multiplied by 1 will give you 4, 5 multiplied by 1 will give you 5, 6 multiplied by 1 will give you 6. So I can take 6, 1. Okay, similarly I can take in the second row, I can take 3, 2, because 3 2s are 6. Similarly in the third row I can take 2 and 3, because 2 multiplied by 3 will give you 6. I cannot take 3, 3 because 3 3s are 9. When I multiply 3 3s it will give 9. So I'll take 2, 3, and then in fourth I cannot take anything because 2 4s are 8, 3 4s are 12. I cannot take anything. Here also I cannot take anything. You can check. And the last one, 1, 6. Yes, 1 6 are 6. I can take that. 2 6 are 12. I cannot take that. So others are ruled out. So these are the favorable outcomes. 1, 6, 2, 3, 3, 2, 6, 1. So N of A is 4. The favorable outcomes, and the total possible outcomes is 6, 36. So P of A is equal to N of A divided by N of S. So what is your N of A? 4 divided by 36. Both are divisible by 4. So 1 by 9. So this is the probability of success. Okay, students. I'll be uploading what are the problems to be solved. Okay, in your from your textbook. You can solve those problems. Okay, you can take all the notes and solve all these problems. Okay, students, stay focused and concentrate in your studies. Hope you understood the concept so far. Okay, so today we discussed about the probability, the definition of probability. Okay, that is N of A by N of S. Number of favorable outcomes whereby total possible outcomes. We discussed about experiment, outcome, what is equally likely outcomes, what is the meaning of sample space, sample point, event. Okay, and then we also discussed about the type of events. We discussed about the mutually exclusive events. All right, we also discussed about the general rule. Sure event means probability will be 1, impossible event means it will be 0, and some other rules in probability. Okay, and then we also discussed about the complementary events, and then we also discussed what is the meaning of complementary events, correct? And then we also solved some of the problems in probability, right, students? So you can make a note, and after completing it you can submit under assignment on probability. Have a good day. Thanks for watching the video. Bye bye.